Alright guys, welcome back. We're going to be solving out a question from the third chapter of the Mechanics of Materials by Johnston, and we have question 9 from the third chapter, and the torques shown are exerted on pulleys A, B, C. And we know that both shafts are solid, and we need to determine the maximum shearing stress in shaft AB and shaft BC. One thing I noticed in this question, in some versions of this textbook, the diameter of the shafts are missing. So that's actually part of the givens of the question. We know this part is 1.3 inches and the part BC, the diameter is 1.8 inches. So that's part of the givens in the question. If you don't see it, don't freak out. We need this information to solve this question. And we talked about the formula that we have for these kind of questions, the elastic torsion formula. So the maximum shearing stress equal to J, which was the moment of inertia. So our J is basically 1/2 of pi times the radius. We can show it with rho or C to the power of 4. So if you just put that in here, 1/2 of pi C to the 4, C is actually R rho. So we can cancel these out. The formula is turning to 2t over pi rho cube. So the rest of it is just putting the numbers in here, but we need to figure out the torque in each member. We have two different members, and remember we talked about at the beginning of this textbook, chapter 1, we talked about how to find the internal forces, and we have different rods with different diameter, where when we want to, let's say we have this different forces in here, and when we want to find the A, B, C, and when we wanted to find the internal force in the AB part, we were doing a section right before the end, and based on the equilibrium condition that we have, the internal force, like in here, let's call it Fi or whatever, F1, F2. Fi will be equal to F1 plus F2 because of the equilibrium equation. It's kind of like the same idea in here too. It's just instead of force, we have torque. So we're going to do the same cut that we were doing in the previous one. So right before the pulley B, so we have this torque, which means we have to have the internal torque of 3.6 kip. And so that's going to be the torque in AB. So 2 times 3.6 kip inch over pi times the rho in here is the radius. Keep in mind that we have the diameter, so we need to divide it by 2 all to the power of 3. This is going to give us the maximum shearing stress in AB. So 2 times 3.6 divided by pi times 1.3 divided by 2 all to the power of 3. And this is going to give us 8.35. Again, keep 3 significant figures. And that's going to be the maximum shearing stress, and it's going to be in, KSI. So the unit will be in KSI because it's kip per inches squared, so it's going to be KSI. So that's going to be the A part of the question. For the B part, same idea. This time we're going to do our cut right before C, and now we have to deal with two different torque in here. We have 3.6 in this direction, and we have 10.4 in that direction. So the overall direction is going to be this, and it's going to be 10.4 minus 3.6. Same formula, gonna be 2 times 10.4 minus 3.6 over pi times the diameter is also different. The diameter is 1.8, again divided by 2, so 0.9 all to the power of 3. Let's see what we get here. So just do a ratio, 2 times 10.4 minus 3.6 over pi times 0.9 to the power of 3. And this is going to give us 5.94 KSI, and that's going to be the answer for the B part. Again, three significant figures in engineering problems. And yeah, that's pretty much everything for this. Again, if you're seeing this question and the version that doesn't have the diameter of the shaft, that information is actually missing. So we need the diameter in here. Hope everything is clear. Let me know if you guys have any questions. You guys take care. See you in the next video. Have a good one.